Welcome to kNawire.
Okay, we need to calculate delta H in kilojoules per mole of the dissolution of magnesium sulfate. Okay, so we had 5.21 grams of mag sulfate. And also say this is in kilojoules per mole. Okay. And we put it in water, and that increased the water's temperature by 6.70 degrees C. And we had 10.0 milliliters of water. Great. So what is the equation that we need here? Well, we need that the heat of a reaction, in this case a dissolution, is equal to the mass, right, of the water heated, right, times the heat capacity of the water heated, okay, times the change in temperature of the water heated. And this will tell us how much heat was generated in joules, or whatever units CP is in, from our reaction. Then, if we can figure out how many moles of magnesium sulfate we have, then we can have Q per mole, and that's going to basically be delta H, right? So we've got to figure out, for one, we need CP, which they give us for water is 4.184 joules per gram delta C, okay? And we need the mass of the water. They told us it was 100 milliliters. But they also tell us we can assume that the density of water is 1.0 gram per milliliter, which means we had 100.0 grams H2O. So with this information, we should be able to calculate Q and get the heat that was released when we dissolved 5.21 grams of magnesium sulfate. That is, we get 100.0 grams times 4.184 joules per gram per degree C times 6.70 degrees C. And what we get is 100.0 times 4.184 times 6.7. I get I missed it. There we go. 2,540 joules. Okay. Now, because we know this was heat released, I'm going to note that down, right? The water got hotter, so this was heat released. Okay. Now, we know joules released. Now we need to basically figure out, well, how many moles of magnesium sulfate, because we want to know joules per mole. Really, we want to know kilojoules per mole, so we might go ahead and just rewrite this now as 2.540 kilojoules, right? Remember, there's 1,000 joules in a kilojoule, so to convert joules to kilojoules, we divide by 1,000. So there were 2.540 kilojoules of energy released into the water, which is how its temperature was raised. Now we just need to figure out the molecular weight of magnesium sulfate. Which is 120.366 grams per mole. And use that to calculate how many moles of magnesium sulfate we had. Remember that this also implies that there is 1 mole for every 120.366 grams. Right? A molecular weight tells us grams per mole, but it also tells us moles per gram. We just need to flip it over. Okay, and that's going to be more useful because we have 5.21 grams magnesium sulfate, And the way algebra works, we need grams of magnesium sulfate on the bottom of this fraction if we're going to be able to cancel the units of grams magnesium sulfate so that we can get mole magnesium sulfate. Okay, so effectively, we're dividing 5.21 by 100.36. And so the number of moles we get is 0.04328 mole magnesium sulfate. Okay, so now we've got kilojoules, we've got moles. I think we're ready to go. So we got delta H dissolution of magnesium sulfate equals, then we put the kilojoules on top, 2.540 kilojoules per 0.04328 mole. Okay, and then we're going to calculate this. We're just going to put this in a calculator because what it's going to do is instead of telling us kilojoules per 0.04328 moles, it's going to tell us kilojoules per mole. All we need to do is put this in the calculator in the units. It'll simplify down to a more standard form, if you will. So 2.540 divided by 0.04328, I get 58.69 kilojoules per mole. Now, I will point out that this is a heat of dissolution, and this amount of heat was released. And when heat is released, delta H is negative, right? So it would be customary to put a negative sign in front of this, because if the heat of dissolution was positive, that would imply we need to add heat for it to dissolve. Instead, what happens is we put it in water, it dissolves, and the water gets hotter. So it's the other way around. That's why this is a negative value. Okay.